In this episode, we are stepping into a part of the CISA body of knowledge that feels especially practical because it follows the path of a system from idea to reality. Domain 3 is about how organizations decide they need a new system, how they choose whether to buy, build, or adapt one, how they guide development work, and how they move that system into real business use without creating avoidable confusion or risk. For a beginner, this matters because many technology problems are not caused by the final system alone, but by weak choices made long before launch, when goals were unclear, controls were delayed, or the project was rushed forward without enough discipline. A system can fail in production because the wrong solution was selected, because requirements were misunderstood, because testing was shallow, or because implementation was handled carelessly. This domain teaches you to see that full chain. It helps you understand that acquiring and developing systems is not just about getting new technology into the building, but about doing it in a controlled way that supports the business and protects information. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyberauthor.me in the Bare Metal Study Guide series. A useful way to understand this domain is to think of it as a guided journey rather than a single technical event. A business notices a need, explores options, approves a project, defines requirements, designs the solution, develops or configures it, tests it, implements it, and then hands it into ongoing operation. That full path is often described through a System Development Lifecycle, SDLC, which is simply a structured way to manage how systems are planned, created, changed, and deployed. Even when organizations use different delivery styles, the same core questions still appear. Why is this system needed? Who approved it? What problem is it solving? What controls are required? How do we know it works? And what could go wrong if it is put into use too early? Domain 3 gives you a broad understanding of those questions so you can see the logic behind the process instead of memorizing isolated terms that seem disconnected from real work. One reason this domain matters so much is that information systems sit close to core business activity. A poorly chosen sales platform can hurt revenue, a rushed payroll implementation can damage employee trust, and a weak patient record system can create both operational and privacy problems. These are not narrow technical mistakes that stay hidden inside the technology team. They become business failures because the system was supposed to support the business in a dependable way and did not. That is why acquisition, development, and implementation are really governance and risk topics as much as they are technology topics. Leaders are making decisions about money, timing, control, compliance, and operational dependence every time they approve a new system or major enhancement. If those decisions are weak, the organization may spend heavily and still end up with a service that frustrates users, creates exposure, or needs extensive repair after launch. The acquisition part of this domain begins with a simple but important question. What is the organization actually trying to obtain? Sometimes the answer is a completely new system built internally. Sometimes it is commercial software purchased from a vendor, and sometimes it is a hosted or outsourced service that the organization configures and manages through a third party. Each of those paths brings different advantages and different risks. Buying a ready-made solution may be faster than building one from scratch, but it can also create dependency on a vendor and limitations in customization. Building internally may offer greater control over features and design, but it usually requires more time, planning, skilled staff, and ongoing support. A good acquisition decision is therefore not based on excitement about technology alone. It is based on business need, realistic capacity, cost, time, risk, compliance requirements, and whether the organization can truly support the solution after it goes live. That leads naturally into one of the most important ideas in this domain, which is that systems should begin with business requirements rather than technical preference. If people do not agree on what the system must do, who will use it, what data it will handle, how reliable it must be, and what risks need to be controlled, the project begins with confusion built into it. A team may work hard for months and still disappoint users simply because it solved the wrong problem or misunderstood the real priorities. Good requirements do not have to be written in overly complex language, but they do need to be clear enough that designers, developers, testers, managers, and users can understand the intended outcome. They also help the organization decide later whether the solution was actually successful. In this sense, requirements are not just planning documents. They are anchors that hold the project to the original business purpose and reduce the chance that the work drifts into something expensive but misaligned. Once requirements are understood, design becomes the stage where the organization decides how the solution should work at a high level. Design is about structure, relationships, data movement, user interaction, dependencies, resilience, and control. This is where the organization should already be asking whether access will be restricted properly, whether changes can be tracked, whether sensitive data needs protection, whether the system must recover from outages quickly, and whether the design matches the scale of expected use. A common beginner mistake is to think controls are added near the end after the main system has already been planned. In reality, controls are most effective when considered early, because it is much easier to design access rules, logging, approval paths, separation of duties, and recovery needs into the solution than to bolt them on later under deadline pressure. Good design is not just about making the system function. It is about making the system function in a way the organization can trust, support, govern, and explain. Development is the stage many people picture first when they think about building systems, but Domain 3 treats it as one part of a larger controlled process rather than as the entire story. Development may involve writing code, configuring commercial software, creating workflows, designing interfaces, or integrating one system with another so information moves correctly across business processes. What matters most at this stage is discipline. Work should follow approved requirements. Changes should be tracked, responsibilities should be clear, and documentation should not be ignored simply because deadlines are tight. Even if the organization uses a modern and flexible approach, it still needs consistency in how work is reviewed and moved forward. Good development practice reduces confusion, limits avoidable defects, and makes later testing far more meaningful. Poor development practice may produce something that appears to work in a demonstration but proves unstable once real users, real data, and real operational pressure begin to interact with it. Project governance sits above all of this and gives the effort direction, authority, and accountability. A project without governance often turns into a confusing stream of activity where work is happening but nobody is fully sure who can approve scope changes, accept risk, release funding, or declare the solution ready for implementation. Good governance establishes sponsorship, decision rights, escalation paths, reporting expectations, and oversight over cost, time, scope, quality, and risk. This is important because system work almost always competes with other organizational priorities, and without clear governance, the project can drift, expand, or become driven by the loudest voices instead of the most important business needs. Governance also helps prevent unrealistic promises. A leader may want rapid delivery, but governance should still force the conversation about testing, readiness, staffing, and control implications. When learners understand governance, they stop seeing projects as purely technical undertakings and begin seeing them as managed business efforts that happen to use technology as the delivery vehicle. Testing is one of the clearest control points in the full life cycle because it is where the organization tries to reduce uncertainty before the system affects real operations. Testing is not only about asking whether a screen opens or whether a calculation appears correct once. It is about confirming whether the solution behaves as expected under realistic conditions, whether connected parts work together, whether security and control requirements function properly, and whether the system is ready to support business activity without unacceptable failure. Effective testing depends on clear expectations, meaningful scenarios, and enough independence to challenge optimistic assumptions. If testing is shallow, rushed, or treated as a formality, serious weaknesses can pass into production and then emerge when the business is already depending on the system. That is why this stage deserves so much attention in audit and management discussions. It is one of the last opportunities to find defects, design problems, or control gaps before they become operational incidents that are far more costly to correct. Implementation is where the organization moves from preparation into actual use, and this stage often feels exciting because visible change is finally happening. It is also one of the riskiest moments in the whole life cycle because real users, real data, real schedules, and real business expectations are now involved. Implementation may include data conversion, user training, communication with affected teams, change approvals, final validation, transition planning, and decisions about whether the new system will replace the old one all at once or in a more gradual manner. A beginner should understand that successful implementation is rarely just a technical switch being turned on. It is a managed change event that has to account for business continuity, user readiness, support needs, fallback options, and the possibility that something unexpected will happen under live conditions. When implementation is rushed, even a well-designed system can appear to fail because people were not prepared, data was not handled carefully, or support processes were not ready to absorb the change. After implementation, the work is not really finished, even though many inexperienced observers think the project is over the moment the system is live. The organization still needs to confirm that the expected business benefits are appearing, that users are able to perform their work effectively, that incidents are understood and resolved, and that ownership has transitioned properly from the project team into ongoing operations. This period is often where hidden weaknesses emerge, because real-world use exposes patterns that were not fully visible during planning or testing. A system may technically meet requirements and still create support burdens, performance issues, or process confusion that management needs to address. That is why post-implementation review matters. It helps the organization compare intended outcomes with actual outcomes and learn whether the acquisition, development, and implementation process worked as intended. In a healthy environment, this review is not a blame exercise. It is a chance to strengthen future projects by learning honestly from what went well and what did not. Because this domain is an overview, it is also important to understand some of the common risks and misconceptions that run across the entire life cycle. One common misconception is that the best technology choice is always the one with the most features, when in reality the better choice is often the one that fits business needs, support capability, and control requirements most sensibly. Another misconception is that speed always represents success. Fast delivery can look impressive until weak requirements, poor testing, or incomplete training create months of rework after go-live. A third misconception is that business users and technical teams can work separately until the end and then simply connect their efforts during implementation. In practice, strong outcomes usually depend on consistent communication between them from the beginning. Domain 3 teaches you to notice these misunderstandings early, because they often sit underneath project failure, overspending, user resistance, and audit findings that later appear to be isolated problems when they were actually symptoms of weak discipline all along. From an audit perspective, this domain teaches you where control and assurance questions should be asked throughout the life cycle rather than only after implementation. A certified information systems auditor, CISA, learners should be alert to whether projects are properly approved, whether requirements are documented and reviewed, whether risks are identified, whether controls are considered during design, whether testing is meaningful, and whether implementation is managed in a way that protects business operations. The auditor is not merely checking whether a new system exists. The deeper concern is whether the organization followed a disciplined process that made good outcomes more likely and weak outcomes less likely. Evidence may come from business cases, feasibility analysis, project governance records, design approvals, testing documentation, implementation plans, issue logs, and post-implementation reviews. When you think this way, Domain 3 becomes much easier to understand. It is not a loose collection of project terms. It is a connected story about how organizations introduce system change responsibly. Another important beginner takeaway is that Domain 3 connects directly with the other areas of CISA study rather than standing alone. Risk concepts from earlier material appear when organizations decide what level of project risk is acceptable and which controls must be built into the solution. Governance ideas appear in project oversight, sponsorship, decision-making, and accountability. Operational thinking appears when the new system must eventually be supported, monitored, maintained, and integrated into everyday business activity. Even vendor management can become part of this domain when the system is purchased or hosted by an outside provider instead of built entirely in-house. This connection matters because learners sometimes try to study each domain as if it were sealed off from the others. In real organizations, system acquisition, development, and implementation are where many earlier governance, risk, and control ideas become visible in concrete action. That makes this domain especially valuable because it shows how abstract concepts become real decisions with real consequences. By the end of this overview, the main picture should feel much more coherent. Domain 3 is about how organizations obtain new systems or major changes in a controlled, purposeful way, from the first business need through requirements, design, development, testing, implementation, and the move into ongoing use. It matters because a system that is chosen badly, built carelessly, or launched without discipline can damage operations, waste money, weaken control, and frustrate the very people it was supposed to help. As you continue forward, keep noticing that the strongest projects are not the ones that simply move quickly or sound innovative. They are the ones that remain aligned to business purpose, manage risk honestly, design controls early, test realistically, and implement change in a way the organization can absorb and support. If you hold on to that mindset, this domain becomes less about memorizing project vocabulary and more about understanding how responsible system change actually happens. That is exactly the kind of understanding that makes the rest of Domain 3 much easier to learn.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit baremetalcyber.com.